Hello, this time we're going to determine the range of another quadratic function. Then this time the parabola opens down. To determine the range of this quadratic function, the first thing we did is that we're going to regroup. We put the negative x squared plus 4x in one parentheses. And we are going to factor out the negative sign. After factoring out the negative sign, we will have x squared minus 4x minus 3. And then inside the parentheses, we're going to add a 0. We're going to add a 0, okay? We're going to add a 0, but this 0 is chosen very carefully, okay? This 0 is made of a number. The first number is going to make a perfect square, and the other number is going to balance the equal sign. So we're going to add a 4 and minus a 4. Okay? Because x squared minus 4x, if we factor x squared minus 4x plus 4, that's going to be x minus 2 squared. That's where we want. So as a result, we get negative of, we're going to insert a bracket here. These 3 will make the perfect square of x minus 2 squared. And there's a minus 4. So the minus 4 stays there. And minus 3 was outside. Okay. And then we're going to apply the negative sign to the perfect square. So we're going to get a negative x minus 2 squared, and negative 1, negative sign multiply negative 4, that's going to be a plus 4 minus 3. So in the end, we're getting the final form, which is going to be plus 1. Okay, so here we just want to put a little note here. You can factor just to explain this. So maybe I will just put this on the side. Okay, so that explains the reason why we add 4 and subtract 4 at the same time. So with this form given, we ended up with f of x equals to negative x squared plus 4x minus 3. And there's another form which is equal to the given form. But in the latter form, we can identify the number to make the perfect square 0. And that number is 2. So when x equals to 2, f of 2, okay, if you replace x by 2 in either form, and we're going to get the output equals to 1. This tells us the vertex is 2, 1. Okay, we can see this well by transformation from x squared. Okay, so from x squared, we have graphed this function in module 2 right here. So from x squared, we're going to do x minus 2 squared. We're going to do x minus 2 squared. And we know that x minus 2 squared is a shifting to the right, horizontal shift by 2 units. Okay, by 2 units. So I'm going to make some adjustment to the picture. Okay, So from x squared, we get to shift 2 units to the right, and we will get x minus 2 squared. X minus 2 squared. I think we need a little bit more adjustment. Okay, so let's make it negative 10. Okay, so this will make it negative 10 over here. So I'll make that adjustment. So we have x squared shifted to the right by 2 units. And now we're gonna get another curve. X minus 2 squared by 2 units. So this will be the green. So now the vertex, you see, is shifted to 2, 0, 2, 0. And next, we're going to shift to negative x minus 2 squared. X minus 2 squared. And this is a shift that's flipping over, okay? Just like negative x squared, okay? So let me bring the other picture we have done earlier for our reference, right? This is the picture I referred to. X squared, negative x squared is a flipping over, right? It's x squared, negative x squared. So now we have a negative x minus 2 squared. So this green curve will flip over. Will flip over. X minus 2 squared with a negative sign in front of it. So I'm going to change the color to blue. Let me change it blue. Let's, how about this one? Purple. Magenta, light blue. Okay, that should do it. Okay, you can see the vertex stays at 2, 0. And last but not least is finally we're getting, no, sorry. Finally, we're getting shifted up by 1 unit. So now we're graphing the final one. Okay, we're graphing the final one, and this one is going to be negative x minus 2 squared shifted up by 1 unit. By 1 unit. Okay, so the final one we're going to use red. So this is shifted up by 1 unit. So the final vertex here, okay? If you keep track of the shifting, right? The vertex is shifted from 0, 0 to 2, 0, stayed at 2, 0, and shifted up by 1 unit. So this vertex is going to be 2, 1, 2, 1. Okay, so you look at the red curve. You look at the red curve, and then we know the range. Okay, then we know the range. Ooh, sorry, I'm going to put back the vertex here. Okay, which is 2, 1. And as a result, we know the range. We know the range is from negative infinity to positive 1. Okay, so now here I'm going to have to shift it. Maybe I can write it down here. Clear all. So the vertex, as we saw earlier, right? These shifting when the input is 2. My input is 2. The height is 1. Output is 1, and that is the highest point. That's the highest point there is. So the range is from negative infinity to positive 1. Okay. In other words, for any input, for any value x, okay, this function is always greater than or equals to 1. Always greater than no output, no function value will ever be exceeding 1. So that's the meaning of the range. Thank you for watching.